We're going to look for an inverse function for the sine function. This is the graph of y equals sine x, and I'd like to think about an inverse sine function. You may remember from your past that in order for a function to have an inverse, it has to be 1-to-1, which means it has to pass the horizontal line test, which means that any horizontal line can go through that function one time and only one time, and we're in trouble because that horizontal line goes through my graph infinitely many times. So the sine function actually fails the horizontal line test completely. It's not 1-to-1 at all. What does that mean? Does that mean, oh well, there is no inverse sine function and this is a really short video? No, it does not. It does not mean that. What it does mean is that we're going to have to limit the domain of the sine function to just a piece that is 1-to-1. There are actually infinitely many ways of doing that. The standard one is I'm going to start here at a minimum at -pi/2. And I'm going to go to the maximum, the next maximum, at +pi/2, and take just that little piece. On that little piece, my sine function is 1-to-1. I get all possible values of the domain of the range, from -1 to 1. And this little piece does pass the horizontal line test. So if I look only at that little piece of the sine function, it does make sense to talk about an inverse sine function. So this little piece, this is y equals sine x on the domain -pi/2 to +pi/2. The sine function is 1-to-1 and has an inverse. We might as well mention the range at the same time. The range of the sine function, I hit every possible value in the range from -1 to 1 on that little piece. So then, what about this inverse? Here's how we're going to write it. We're going to read this. Y is the inverse sine of x. This is not sine to the -1. This is not sine with that little exponent thingy up there. This is the inverse sine of x. Or equivalently, sometimes you see y equals arc sine x, and those two are completely interchangeable. They mean exactly the same thing, the inverse of the sine function. You may also remember from your past that for inverse functions, the domain of the original function is the range of the inverse. That means the range of this inverse sine function, it goes from -pi/2 to +pi/2, and the domain of the inverse is the range of my original. So the domain is -1 to 1. All right, so we've defined this inverse sine function. Let's see how it works. If I say, for example, the inverse sine of 1/2, and I would like to evaluate that. What I'm really saying is I'm looking for the angle whose sine value is 1/2 and is in the right range. So I'm looking for the angle between -pi/2 and +pi/2, that's quadrant 1 or quadrant 4, that has a sine value of 1/2. You can actually use the unit circle for this. You're reading it kind of backwards or inside out. I'm looking for a sine value, a second coordinate of 1/2. Between -pi/2 and +pi/2, and that happens at pi/6. So sine of pi/6 is 1/2. The inverse sine of 1/2 is pi/6. Well, let's look at another one. Suppose I want the inverse sine of -√3/2. So I'm looking for the angle that has a sine value of -√3/2 that's in the range -pi/2 to +pi/2. If you look at your unit circle and look in quadrants 1 and 4 for a second coordinate of -√3/2, you're going to find 5pi/3. 5pi/3 is not in the right range. So our answer that we're looking for here is not 5 pi over 3. It's out of range. So what does that mean? What are we going to do? Well, we need to say that angle, because we're in the right place. We're in quadrant 4, but we need to say that angle 5 pi over 3 in a different way so that it falls in the correct range. We're going to name a coterminal angle, so I'm going to go in the negative direction, and that'll be negative pi over 3, still in quadrant 4, but now negative pi over 3 is in the right range. That's supposed to be 3, not a 2. Fortunately, we have the technology. We can fix that. There it is. Negative pi over 3. One more. Suppose I want to evaluate the arc sine of negative 1. So I'm looking for the angle between minus pi over 2 and plus pi over 2 that has a sine value of negative 1, and that'll be negative pi over 2. And that's the inverse sine function.